In this video, we will see how to solve the differential equation for the RL circuit, where R is for resistor and L is for inductor. You can see this is the diagram which we analyzed yesterday, and we created a differential equation for it. So we are going to see in this video how to solve this differential equation and get the solution for this differential equation, that is the expression for current. So first we'll write the differential equation as we got after applying Kirchhoff's law. We are going to divide the whole equation by R. So E by R minus I minus L over R di over dt. Then we are going to apply a mathematical trick to make the solution easier, to get the solution in an easier manner. So we are going to take E by R minus I as x. We are assuming to simplify the integration. So the differential function will be d E by R minus I equal to dx. When you do the derivative of this, you get minus di equal to dx. We are doing this because in the equation we have got di which we want to replace. Okay, so let's see. Now we replace E by R minus I as x and di as minus dx to get the new equation. Now you can see that it is more easier to integrate this one, and hence we made the assumption. We simplify by taking the negative out and making it positive, rearrange the sides, rearrange x, dx and dt so that we are able to integrate it. So the equation is minus R over L dt equal to dx over x. We integrate it from the limits 0 to t, and on the right hand side the limits are from x0, which is the initial value of x, to the final value of x. Now we are going to apply the integral rules. So we get minus R over L t. When you integrate dt, you will get t. When you integrate 1 over x, we get ln x. We apply the limits and we get ln x over x0. Now we want to replace x and x0 because that's what we made an assumption. We have to go back to I. So we are going back to our assumption, E by R minus I equal to x. Okay, and we are going to replace x with this expression. For x0 is the initial value of x when t is equal to 0. When t is equal to 0, I is equal to 0, so you get x0 as E over R. We replace this back into the equation. You can see we are replacing x and x0 by its value. Take exponential because our aim is to get the solution of the equation and get an expression for current. Okay. We rearrange the equation for I, and E by R is common, so we take that out common. So we get I is equal to E by R in brackets 1 minus E RT over L.